The precise means by which an ice is generated are still not fully understood. As opposed to fire, which forms the basis of technology as much as widespread destruction, ices are a relatively rare and poorly documented natural phenomenon. While records of ices exist sporadically throughout history, there remains scant photographic evidence. This image, dated to the mid-1970s and believed to have been taken somewhere in the American South during an unseasonably warm winter, is one of the few confirmed images of an active ice. The ice was apparently kindled in either a repurposed fireplace or a designated chamber as a form of central cooling system. There are likely more photographs of ices than historians currently estimate. Prior to the dawn of color film, an image of ice would be difficult to distinguish from that of a fire, and the blue tint of an oxygen-deprived flame can easily be confused with a minor ice. Even stranger, however, are these scarce depictions of ices in visual media of any era, much less clear written accounts of how one is either started or, most importantly, extinguished. A common joke among researchers is that if fire is produced by rubbing two sticks together, then surely an ice will arise if one gently places two sticks next to each other and waits patiently. Perhaps those who first discovered the secret to ice were pillaged, and the colonizers were unwilling or unable to adopt their knowledge. If not that, then it is almost as if a collective understanding was reached, among cultures near and far, that the risks of kindling an ice somehow outweighed its benefits, even among people in whose climate one would especially benefit from a constant, reliable source of cold. Speculation as to why runs rampant further still. Perhaps the Ice Age was not the result of a planet-wide drop in temperatures caused by a meteor strike, but rather the result of an ice which spread out of control, its effects scarring the genetic memory of our ancestors, save for a few unique or foolish souls. Regardless, among scientists, the predominant hypothesis is that an ice functions, as its appearance and name suggest, like the opposite of a fire, a chemical discharge of energy at an atomic level, albeit one in which heat exchange is reversed, dramatically lowering the temperature of the surrounding matter rather than raising it. For this reason, the reaction is also known as cryocombustion. Indeed, to thrust a bare hand into the heart of an ice is to immediately numb one's entire skin, if not contract frostbite. Those of a more spiritual mind believe much the same, except with a far simpler rationale. In a universe of dualities, from light and dark to good and evil, there must be ice to match fire. Not merely a rigid form which emerges when water solidifies, but a flickering, almost living burst of sensation. A means by which the burning fury of fire and all that it represents are truly tempered. With all this in mind, the answer to ice's elusiveness might be all too straightforward. For as much destructive force as an ice surely possesses, it cannot fuel an engine, electrify a computer, or spark a bomb to ignite. It is dangerous, and yet it is not a source of power. What use could humans have for such a contradiction?